Space. Vast, mysterious, full of things that seem impossible. It has fascinated us for centuries, but do we really know everything about it? The truth is, many things we think we know about space are actually myths. These misconceptions appear in movies, books, and even in school textbooks, but science has long debunked them. Does gravity really not exist in space? Is the sun actually yellow? And can astronauts on the ISS float because there's no gravity? Today we're going to expose 10 of the biggest space myths and uncover the truth behind them. Let's begin. It's one of the most common misconceptions about space. Seeing astronauts float around inside the ISS, many people assume that there's no gravity in space. But that's not true. Gravity is present everywhere, even 400 kilometers above Earth, where the International Space Station orbits. So, if gravity still exists, why do astronauts float? It's all because of freefall. The ISS isn't just hanging in space, it's actually falling toward Earth all the time. But here's the trick. The ISS is moving so fast, about 28,000 km, that as it falls it keeps missing Earth's surface. This means it never actually crashes, but instead stays in orbit, constantly falling around the planet. Imagine throwing a baseball really hard, so hard that instead of hitting the ground, it keeps curving around the Earth forever. That's exactly what's happening with the ISS. So astronauts on the ISS aren't in zero gravity, they're just in constant free fall. Myth busted. On to the next one. Space, a vast empty void. No air, no wind, no sound, right? Movies like Star Wars show epic space battles filled with loud explosions, roaring engines, and laser blasts, but in reality there's no sound in space. That's because sound is a mechanical wave. It needs a medium, like air or water, to travel. And in the vacuum of space, there's nothing to carry sound waves, so if you were floating in space, you wouldn't hear a thing. But does that mean space is completely silent? Not exactly. Space is full of electromagnetic waves, radio waves, X-rays, and even plasma waves, and NASA has recorded these waves from planets and stars, converting them into sound. Jupiter produces eerie, low-frequency hums, Saturn emits haunting whistles, and some pulsars generate rhythmic ticking sounds. So, while space is silent in the traditional sense, when we translate its electromagnetic waves, it turns out to be a vast cosmic symphony. Myth busted. Let's move on. Everyone knows the sun is yellow, right? That's how we draw it as kids, and that's how we see it in the sky. But in reality, the sun isn't yellow, it's white. The sun emits light across all visible wavelengths, from violet to red. When combined, this creates white light. So why does the sun look yellow from Earth? It's all because of our atmosphere. As sunlight passes through the atmosphere, shorter wavelengths, like blue and violet, are scattered in all directions. That's why the sky appears blue. The remaining light, which is mostly in the yellow and red spectrum, gives the sun its yellowish appearance. But if you looked at the sun from space, where there's no atmosphere, you'd see it as pure white. And what about sunsets? Why does the sun turn red or orange? It's the same reason. When the sun is near the horizon, its light has to pass through more of the atmosphere, scattering even more blue light and leaving only red and orange wavelengths. So the sun isn't yellow, it just looks that way from Earth. Myth busted. Let's move on. The dark side of the moon. It sounds mysterious, almost sinister. Many people believe that there is a part of the moon that never sees sunlight. But that's a myth. There is no such thing as a permanently dark side of the moon. What actually exists is the far side, which is always facing away from Earth. But it still gets sunlight just like the side we see. The reason we only ever see one side of the moon is because of tidal locking. The moon rotates on its axis at the exact same rate as it orbits Earth. This means one hemisphere is always facing us, while the other always faces away. But when we have a new moon, the side facing Earth is in total darkness, while the so-called dark side is actually in full sunlight. In 1959, the Soviet spacecraft Luna 3 was the first to photograph the far side of the moon, revealing that it looks very different from the near side. It has far more craters and fewer lunar maria. So no part of the moon is permanently dark. It all depends on its position relative to the sun. Myth busted. Next one. The name black hole sounds like it describes a giant cosmic void, endlessly sucking up everything around it. Many people believe that black holes act like vacuum cleaners, pulling in planets, stars, and even light. But in reality, a black hole is not a hole at all. It's an incredibly dense object with extreme gravity. Black holes form when a massive star collapses under its own gravity, compressing all its mass into a tiny, infinitely dense point called a singularity. The gravitational pull near a black hole is so strong that nothing, not even light, can escape once it crosses the event horizon. But black holes don't actually suck things in. If our sun were suddenly replaced by a black hole of the same mass, Earth and the other planets would keep orbiting just like before. The only difference, it would be very, very dark. The real danger comes if you get too close to the event horizon, then there's no escape. You'd experience spaghettification as the intense gravity stretches you into a long, thin strand before you cross the point of no return. So, black holes aren't cosmic vacuum cleaners, they're just regions of extreme gravity. Myth busted. Let's keep going. Hollywood movies love to show people instantly exploding when exposed to the vacuum of space. Skin bursts, blood boils, eyes pop out. Dramatic, right? Well, real science says otherwise. While space is deadly for humans, you wouldn't explode. Here's what would actually happen. Within seconds, the air in your lungs would escape, and you'd lose consciousness due to lack of oxygen. Your blood wouldn't boil because your skin and circulatory system are strong enough to hold pressure for a short time. You wouldn't freeze instantly since space doesn't conduct heat like air or water. In fact, NASA once accidentally exposed a test subject to near-vacuum conditions for 14 seconds. He survived with no lasting damage. If you were rescued within 1-2 minutes, you could potentially survive without permanent injury. So while space isn't forgiving, it wouldn't cause you to explode on the spot. Myth busted. Next up. At night, the moon shines brightly in the sky. Some people believe that the moon produces its own light, like a star. But in reality, the moon doesn't generate any light at all. It simply reflects the sun's light. Its surface is covered in regolith, a layer of fine dust and rocks that reflects about 12% of the sunlight that hits it. The rest is absorbed, which is why the moon appears much dimmer than the sun. If the moon truly produced its own light, it wouldn't go dark during a lunar eclipse when Earth blocks sunlight from reaching it. So the moon doesn't glow on its own. It just acts like a giant cosmic mirror. Myth busted. Moving on. 66 million years ago, a massive asteroid struck Earth, wiping out the dinosaurs. Many believe it was an instant apocalypse, a massive explosion, and poof, the dinosaurs were gone. But reality was much more complicated. Yes, the asteroid impact near the Yucatan Peninsula was catastrophic. It released energy equivalent to billions of nuclear bombs, causing tsunamis, wildfires, and massive shock waves. But the dinosaurs didn't die immediately. The real killer was what came after. The impact threw gigantic amounts of dust and ash into the atmosphere, blocking sunlight for months or even years. This caused a drastic drop in temperature, killing plants and disrupting the entire food chain. First, the plant-eating dinosaurs died from starvation. Then, the predators that relied on them perished. The extinction took thousands of years, not minutes. So, while the asteroid started the process, the true mass extinction was a slow-motion disaster. Myth busted. Moving on. People often claim that the Great Wall of China is the only man-made structure visible from space. But this is a myth. Astronauts aboard the International Space Station, which orbits about 400 kilometers above Earth, have said that they cannot see the Great Wall with the naked eye. The reason? The wall is long but very narrow, and its color blends in with the surrounding landscape. However, astronauts can easily see cities, roads, airports, and large artificial islands, especially at night when lights illuminate them. Chinese astronaut Yang Liwei, who went to space in 2003, confirmed that he couldn't see the Great Wall from orbit. So, while it's an impressive structure, it's not the most visible thing from space. Myth busted. Let's go to the last one. When we think of space, we imagine a freezing, icy void where everything instantly turns to ice. But is space really that cold? The truth is, it depends. Space itself has no temperature because temperature is a measure of how fast particles move, and in a vacuum there are almost no particles. If you're in the shade, far from any heat source, temperatures can drop to minus 250 degrees Celsius. But if you're in direct sunlight, temperatures can reach over 250 degrees Celsius, hot enough to boil water instantly. That's why astronauts' spacesuits are designed with both insulation and cooling systems so they don't freeze in the shadows or overheat in the sun. So, space can be freezing, but it can also be scorching hot, depending on where you are. Myth busted. As you can see, space is full of surprises, and so are the myths surrounding it.